Hello students, good morning. Welcome to the chemistry online classes. So in our today's class we are going to learn the difference between the physical adsorption and the chemical adsorption, right? Today's concept is the difference between physical adsorption and the chemical adsorption. As we know that here the adsorptions are of two types. One is physical adsorption, other one is your chemical adsorption. Now what is meant by adsorption here? Adsorption is nothing but the accumulation of the substance only onto the surface of an object is called to be as an adsorption. So simply if we take an example here, see if I'm going to dip this pen in a glass of water, so we can say that the water will be in touch only onto the surface of the pen, right? But it does not goes inside the pen. That is the we call as the adsorption. If it is only on the surface, we call as adsorption, right? And similarly, if I take an example where if I have the one chalk piece and the chalk piece I am going to dip it into the glass of water, then as you know that the water will not be only onto the surface of the chalk piece, it also goes inside into of a chalk piece. Is it clear here? So that into the body is called as absorption, that is AB, absorption, whereas only on the surface is called as adsorption, that is your AD. Is it clear here? So I hope you understood the meaning of an adsorption. Now let us see what the difference between your physical adsorption and the chemical adsorption. Let us first learn related to the type of physical adsorption here. So the coming to the first point here, the physical adsorption is a weak process, right? Physical adsorption is going to be a weak. Why it is going to be weak here? It is weak because between the adsorbate and the absorbent, it is going to have the weak van der Waals forces. Is it clear here? So because of the weak van der Waals forces, the physical adsorption is going to be the very weak. Is it clear here? Simply we can say it to be as the, when we write on the board with the white chalk piece, what happens here, that there is between the surface of the board and the chalk piece dust, they are going to have the van der Waals forces which is very weak. Just if we apply some small force, it will be rub off, right? So that is also one of the example of your physical adsorption. So physical adsorption is a weak process because of the weak van der Waals forces. So when this process takes place, there is change in energy or exchange in energy, that is we call it as a enthalpy of adsorption, right? The enthalpy of adsorption, the amount of energy change is going to be the very low, that is your 20 to 40 kilojoules per mole, right? So in the case of physical adsorption, the change in energy is going to be the 20 to 40 kilojoules per mole. Now coming to the next point here, physical adsorption is a reversible and also the fast process, right? Physical adsorption is a reversible, we can reverse it, and also the physical adsorption occurs very fastly. Is it clear here? Now move to the next point here. It occurs at lower temperature. So for physical adsorption, low temperatures are the favorable conditions. Is it clear here? Now coming to the next point here, it decreases with rise in temperature. What is here? The physical adsorption going to decrease with rise in temperature. So that means here, as we learn here, the low temperatures are the favorable. So as the temperature is low, the physical adsorption is going to be the more. Okay, if the temperature is going to increase, then the adsorption is going to decrease, that is physical adsorption is going to decrease. Is it clear? Now coming to the next point here, the physical adsorption is not specific. It is not specific. Is it clear here? Now move to the next point here. It is a multi-layered process. Means physical adsorption is going to be a multi-layer. Means multi-layer means, as you know, that number of layers or multiple layers, simply we can call, right? It is your multi-layered process. Now it increases with increase of pressure. So as we are going to increase the pressure, the physical adsorption also going to increases. Simply I can say that pressure and physical adsorption directly proportional to each other, that is the physical adsorption increases, pressure also increases, or pressure increases, physical adsorption also increases. Is it done? Now move to the next point here. It depends on the nature of the adsorbate only. Okay, so physical adsorption depends only on the case of the nature of the adsorbate, so on which the adsorption is going to takes place. It depends only on that substance. Adsorbate is nothing but the substance on which the adsorption is going to take place is called as your adsorbate. Is it clear? So the physical adsorption depends on the type of adsorbate we are going to select. Done. Now coming to the next point here, activation energy is low, right? To activate the process, nothing but to start the physical adsorption, we need some energy. That energy simply means in case of physical adsorption is going to be the very less. Okay. Now desorption is easy due to weak van der Waals forces. What is desorption means here? The opposite of adsorption. As I told you in the starting, when you rub means when you are going to write on the board with a chalk piece, right? That is adsorption. So when you are going to rub the white chalk from the board is called as your desorption. So the rubbing of the chalk piece on the board is very easy. Why it is easy here? Because between the chalk dust and the board surface it is going to be a van der Waals forces. Is it clear here? So hope you understood these points. Next, let's move to the next points here, that is regarding chemical adsorption. So as you've understood the physical adsorption, it will be somewhat easy for us to explain the chemical adsorption. Done. So chemical adsorption is a strong process. So why it is going to be the strong process here? It is a strong process because here in this case we are going to have the strong chemical. So in this case of your chemical adsorption, as we know that it is a strong. Why it is strong here? Because between the adsorbate and the adsorbent they are going to form the strong chemical bonds. So because of the formation of a strong chemical bonds, the chemical adsorption is going to be the strong in nature. You take an example of that. Suppose if you are going to have a wall paint, right? If you are applying the paint onto the wall, here wall is going to be act as your adsorbate and the paint is your adsorbent. So paint will get absorbed onto the wall. So between the wall and the paint, strong chemical bonds are going to form. Therefore, the paint is going to stick strongly with that of your wall. That's why it is an example of your chemical adsorption. That is, it is strong. Now let's see the next point here. Enthalpy of adsorption is high. So during this chemical adsorption, the energy exchange is going to be the very much high. It is going to be a 40 to 400 kilojoules per mole. And as we know that they are going to form the strong chemical bonds, therefore it is irreversible process. We cannot reverse it. Similarly, it is taking time to form the bond, therefore this is called as a slow process. Okay. Now it occurs at the higher temperature. The higher temperature are the favorable conditions for chemical adsorption. It increases with increase in temperature. So as the temperature increases, the chemical adsorption also increases. Okay. So it is highly specific. It is going to be highly specific, means it does not occur everywhere. There are some specific conditions where it only takes place. Okay. Now it is an unilayered process. Okay. Chemical adsorption is a unilayer. Uni means what here? One. So chemical adsorption is a single layer, is a monolayer process, or simply called as unilayer. The effect of pressure is negligible, means the chemical adsorption does not get affected with the pressure, means pressure has not any effect onto the adsorption, or simply we can call the pressure will have a negligible effect on the chemical adsorption. Okay. Now coming to the next point here, it depends on the nature of both adsorbate and the adsorbent. Okay. It depends on the both the one here, that is the adsorbate and the adsorbent. Is it clear here? Now activation energy is high, means to start a process, or simply I can call for a chemical adsorption to occur, the amount of energy required is somewhat higher, right? Therefore the activation energy is high. Desorption is not easy due to the strong chemical forces or strong chemical bonds. So desorption means here the reverse of chemical adsorption is very difficult to take place, as they are going to form the strong chemical bonds between the adsorbate and the adsorbent. Is it clear? So these are the few differences between the physical and the chemical adsorption. So in the examination, mostly he is going to ask you to write any 4 differences between the physical and the chemical adsorption. So as we have discussed the level differences here, you can learn any of the 6 to 7 differences, so that you can remember all the 6 and 7 and you can write in the examination, right? But they ask you to write only the 4. Is it clear, this one here? So hope you understood the today's topic. You learn this answer. Again we will be having the next class where we are going to have the next session, right? Thank you.